This video just shows how you can insert a scatter plot for data in Microsoft Excel. We'll also go on to look at correlation and regression very briefly. So here we have a very small data set, but it's enough to illustrate the point about scatter plots and correlation. A lot of the variables here, such as job satisfaction, for example, are categorical or nominal variables and would not be appropriate for scatter plots. What we need for scatter plots are continuous scale variables, such as, for example, age and length of service. Things like salary and number of items sold would also be potentially scale variables. So it's a simple matter to insert a scatter plot. We just highlight the data involved, and you go to the Insert tab, go over to the charts in the middle area, click on the scatter areas, and indeed a scatter plot appears. You can edit the title very readily. And if you click on the whole box and you then click on the green plus sign, you can insert chart axis titles. These are important in order to when you actually present your scatter plot in your report. So my axis title for the horizontal or x-axis is age. And let's put my units, years. You notice actually that Microsoft Excel defaults to put the left-hand column as the horizontal or x-axis. It's worth checking that this is what you want, because what should be plotted on the horizontal axis is the independent variable, the variable that goes up irrespective. On the y or vertical axis, we have the dependent variable. In this particular case, we have length of service, once again in years. It's important that they are plotted that way round. So there's our scatter plot, and that's very easy to generate. We can add further elements if we want to. For example, we can insert a trend line, which illustrates the trend of the data a bit more readily. And we can even, if we want to, put the equation of the line onto that trend line, if that's something that we're interested in doing. So we can go a step further and think about correlation and regression for this data set. In other words, for correlation, how closely are age and length of service linked or correlated, and the regression then takes us back to the appearance of the line. So if we go to our Data tab at the top and then go over to Data Analysis, we can find correlation and regression over here. If you can't see that on your version of Excel, it's because you need to add in a data analysis toolpack. And you can do that via File and Options and Add-ins. So if I click on Data Analysis and select Correlation, then wants to know what's my input range. So I just highlight these two columns once again. So they need to be next to each other really for this one. So my data are grouped via columns. I do have labels in the first row. I would like my output range to be actually on this sheet rather than a new worksheet. So I'm going to click there and in there, and then just say down there and click OK. And I now have a very small table that shows me that if I plotted age versus age, I'd have a perfect correlation coefficient of 1. What I actually have here is a correlation of coefficient of 0.77, which is fairly high and shows a fairly positive, very strong positive association between the variables. However, I haven't actually got any details of significance on this. So I need to perhaps go a step further and do regression. So if I click on Data Analysis again, go down, click on Regression, This time it wants a little bit more detail. So the input Y range are the data that constitute what I plotted on my vertical axis. The dependent variable, that was length of service. On my X range, my horizontal axis, it was age. I do have labels. My constant is not near 0, so I'm going to leave that blank. My confidence level, it's usually 95%, or put another way, 5% or 0.15, so I'm going to leave it like that, that's fine. I'm not going to bother with some of the bits and pieces down the bottom. I'd like my output range on this sheet. Maybe I'll put it there, and I'll click OK. I have a bit more information now. And the regression statistics actually tell me a few things of interest here. For example, we can see that the correlation coefficient comes up again as multiple R. R squared is sometimes asked for. That is often considered the proportion of the dependent variable that is accounted for by the dependent variable. If we scroll down a bit further, we can see that an analysis of variance has been carried out here, and we can see that there's a significance value given over on the right hand side, and that's repeated in the more familiar version of a p-value down here. Now, if you're not familiar with these terms, that could be a bit confusing. What this number is here is actually 7 times 10 to the minus 5, which I may be able to show, or maybe not here, as a superscript. That to it there. No. It needs to be at the top. That's a really, really tiny number. It means that, in fact, it's the equivalent to 0 and 4 noughts, in fact, which gives me 5 positions of decimal. That's clearly very much smaller than 0.05. So what this is saying is that the chance of the null hypothesis being true here, that there is no significant relationship, is actually very unlikely. And conversely, then, it is highly likely that there is a significant association between these two variables. And obviously it makes sense that the older you are, the more likely you are to have a longer length of service.